Hello and thank you for coming to my YouTube video. Today we're going to be talking about simplifying, adding and subtracting, and multiplying and dividing rational expressions. So fractions are called rational numbers, and rational expressions are expressions that look like fractions. And when we say that we simplify a rational expression, it's like saying we're reducing a fraction. So steps for simplifying, you want to factor the numerator and the denominator, and you want to cancel any common factors and look for restrictions. This term of restrictions might be new to you, and it basically means that you have to make sure the denominator is never 0, so that way the expression will not be undefined. Because remember, we are working with fractions, so when the denominator is 0, the answer is undefined. Let's look at this problem. 16y over 40 x to the power of 2 y to the power of 3. So we look at what times what would equal to y, and you want to come up with the highest number so that way it can be as simplified as possible. Alright, so the only one other than 16 times 1 is 8 times 2. And then to get the expression 16y, it would be 8 times 2 times y. And then we think of in terms of, again, the highest number. So is something times 8 be able to equal to 40? And yes, 8 times 5. And then times x squared times y to the power of 3. Now, since we have these numbers in common, the 8 and the 8, we can cancel them out. And there is a y on top that is in common with the y to the power of 3 at the bottom. So if this is what we can look at it in terms of. If we have one y on top, and then we have 3 y's on the bottom, these are considered common factors. So we're going to eliminate these, and we're left with 2 at the bottom. So your final answer is going to be 2 over 5 x to the power of 2. And because there are more y's on the bottom than there is on the top, you're going to have y to the power of 2 at the top. Now we're going to think of restrictions. Now remember, when looking for restrictions, go back through all your steps and see when you multiply the bottom by any number, will the answer be 0? We're going to do this for the x variable and for the y variable. So x cannot be and y cannot be. And right now for this equation, it looks like that the only restriction is 0, because when you multiply 8 times 5 times 0 squared times y to the power of 3, you're going to get 0 at the bottom. And that obviously is not what we want. And then it's the same for the y variable. So for right now, x and y cannot equal to 0. Now for this equation, we want to do complex trinomial factoring over here. If you don't know how to do that, you can go to my video that I have posted on my channel. But just as a recap, because we cannot simplify this any further, we are going to multiply the 4 by 15, which equals 60. And then we have to find two numbers that multiply to 60 and add to 16. Which is 6 and 10. So we'll rewrite the expression as 4n squared plus 6n plus 10n plus 15. Then we will factor these out. And our final answer would be 2n, or our final answer for this part would be 2n plus 3. And then 2n plus 5. So then this is straight from the numerator. The only thing we're changing right now is the denominator, which is this right here. So 2n plus 3 and 2n plus 5. Now we have these in common with each other. These are in common with each other. So our final answer is 1 because we've erased everything from the numerator. So it has to, we're going to replace that with 1. 1 over 2n plus 5. Now our restrictions, we have to do a little bit more work than just assigning them to 0. If we look at this part of the, in this step in the equation, let's say for example we have 2n plus 3 and we set it to 0. So we know what we want the n not to equal to. So we're going to put the 3 over, so it becomes negative 3 2n, and then n cannot equal to negative 3 over 2, because then it would be equal to 0. We can do the same for the 2n plus 5. We isolate for the n. Negative 5 over 2, n cannot equal to negative 5 over 2. So that is it for simplifying the rational expressions. Now we want to multiply and divide them. And the steps are pretty similar, but when we divide, we take the reciprocal of the second number. So for example, we're going to look at this expression right here. It's pretty long, but we'll go through the steps to complete it. So first thing we want to do is we want to flip or get the reciprocal of the second number in the division problem. So we're just going to rewrite the rest of the question like normal. We can also maybe expand this as well, the 3m squared. So it becomes 9m squared over 5n times over 6 divided by 10 m to the power of 3, 18m. Now we're going to try and cross multiply and see what can go into what. So for example, we have the 9 and we have the 18. So 9 goes into 18. Well, this becomes a 1. And it's going to become a 2 because 9 times 2 becomes 18. And then we're going to look at the 5 and the 10. So again, the 5 also becomes a 1. And then the 10 is a 2. And then the 8 divided by 2, we're going to simplify this one right here. So the 8 will become a 4, and the 6 will become a 3. And here we're just playing with the divisibility rules here, seeing what is divisible into what can we simplify further. And then we have this 4, and we have this 2, so then this becomes a 1, and this becomes a 2, and it looks very messy right now, but we're just trying to isolate this as much as possible. So then at the top, we basically just multiply it by each other. We do 1 times 2, which is 4. And then m2 times m3 becomes m5. So 1 times 2 is 4. m2 times m3 is m5. And then we have the n all on its own. And then that's over 5. Or sorry, that's over 1 times 3 times 1. Which is 3. Then we have the m and the n. Then we go back to getting rid of any common factors. So again, we have 5 m's up top, 1 m at the bottom. 5 minus 1 is 4. And then 1 m cancels out that 1 m. So and then obviously the coefficient of 3, we don't want to divide the coefficients. Sometimes you can, But in this case, dividing 4 by 3, it just looks nicer if we have the 3 at the bottom as a whole number. And then our restrictions in this case. N and M can both not equal to 0. There's no other number that would result in the answer being 0, but N and M cannot equal to 0 because obviously when you multiply something by 0, the answer is 0. And again, that's not what we want. Okay, now we got to, these are all simple trinomials, thankfully. So we can kind of just find the numbers that multiply and add up and then just come up with the two brackets from there. So what multiplies to -4 and adds to -3? So we have m minus 4n. We have m plus n. Because -4 plus 1 equals -3, and -4 times 1 equals -4. And then over m. And in this scenario, we're just doing like finding a GCF, something that's in common with the two terms, and then putting it outside of the bracket. This would be m plus 5n. Then we're going to keep the minus sign the same. Or sorry, is a division sign. So for right now, we're just going to keep it a division sign. And then we're going to find what multiplied equals to 12 and what when added together equals a -7. So it's going to be -3 and -4. And then what when multiplies equals to -15 and when added equals to +2. So that would be it's always better to do your factoring before you do the reciprocal of the second term when dividing. Things are just more cleaner that way and you're less likely to make mistakes. So now we can just rewrite things and then flip the second term. So now we're going to cross out what is the same and all the common factors. So m minus 4n, m minus 4n, m minus 3n, m minus 3n, m plus 5n, m plus 5n. And then we see what we are left over with. So we're left over with m plus n, which comes from here, over m, which comes from here. And then our restrictions is that m cannot equal to 0, because if this equals to 0, then again it would be undefined. But then we have to look at these places right here, where if m equals to 0 here, then we're still going to have the 3n. So it's not necessarily that it can't equal to 0. There are other options. So we can take m plus 5n, for example, equal to 0. So if m equals to negative 5n, it cannot equal to negative 5n, because then it would result in 0, and minus 3n. Make that equal to 0. It's coming from this term right here. Well, then m cannot equal to positive 3n. And then there's this term right here. Again, we have to look at all steps. Even though the m minus 4 was at the top before, we have to look at it when it's at the bottom. We have to go through each step and see what would result in the bottom equaling to 0. And so if we had m minus 4n equal to 0, well then m cannot equal positive 4n. So to make this look a little bit more cleaner, m cannot equal to 0, negative 5n, three n, and 4n. Now adding and subtracting. For this question, 2 over k plus 3 minus 3 over k squared plus 5k plus 6. We're going to look at each fraction, and we're going to see what terms they have. But first, we have to factor this term. So of course, it is a simple trinomial. So what two numbers will multiply to 6 and add to 5? Well, that's 2 and 3. So we'll rewrite this as 2 over k plus 3 minus 3 over k plus 2 and k plus 3. Now we're going to see which denominator has which term. So for example, for this fraction, it has the denominator k plus 3. Well, that's great because the next fraction also has a k plus 3. So they have a common denominator in sense of that term. But now we're looking over at the next fraction, and this fraction has a k plus 2, and this fraction does not. So we need to multiply the first fraction by k plus 2 so that it can be a common denominator. So now that they have the same denominator, we can simplify this a little bit, and we can put a minus 3 here. Just add them on the same fraction. But of course, whatever you do to the bottom of the fraction, you have to do the top as well. So we're going to add a k plus 2 right here. Then we're going to simplify this expression. We're going to expand it. So we're going to do 2 times k and 2 times 2, which is 4, minus 3 over k plus 3 and k plus 2. And then we're going to simplify it even more, so that becomes 2k plus 1 over k plus 3 times k plus 2. Now the restrictions. K cannot equal to negative 3, because k plus 3 equals to 0. When we isolate the k, negative 3, so it cannot equal to negative 3. And it cannot equal to negative 2, and that comes from this expression right here. Now our final example, 3w minus 4 over w squared plus 5w plus 4 plus 2w minus 3 over w squared minus 16. Right, so first we're going to factor all of our terms. So this expression, what multiplies to 4 and adds to positive 5, that would be 4 and 1. And then, of course, for the denominator of the second fraction, we're going to do difference of squares right here. Again, I also have that on my YouTube video on my channel. W plus 4, W minus 4. In the exam, again, we look at which fraction has which terms. So this fraction has W plus 4, this fraction has W plus 4, great. But this fraction does not have W minus 4, and this fraction does not have W plus 1. So we have to fix that now. So the joint bottom is going to be W plus 1, W plus 4, just combining. As long as you have a 1 of all the different kind of terms that are at the denominator, I have 1 W plus 1, 1 W plus 4, and 1 W minus 4. And that means you can combine the numerators at the top because now they're common. So 3W minus 4. Of course, as we said, this fraction is lacking the W minus 4, so we have to add that to the top. And this plus comes from here. And then 2W minus 3. We have to multiply W plus 1 to it. Then we have to expand. So 3W, just going to put it in brackets. So 3W squared minus 12W minus 4W plus 16 plus 2W squared plus 2W minus 3W minus 3 all over W plus 4, W plus 1, and W minus 4. So again, we did the 3W times W to get the 3W squared, 3W times negative 4 to get the negative 12W, negative 4 times W to get the negative 4W, and negative 4W minus times negative 4 to get the positive 16, and then we did the same thing with this term right here. Now we are going to simplify for the final time. So we can drop the brackets and just start combining like terms. So we're going to end up with 5W squared, which is the 3W squared and the 2W squared combined. And then we have negative 17W plus 13. And then W plus 4, W plus 1, and W minus 4. And it is as simple as you can get this equation. Our restrictions is that W cannot equal to negative 4, positive 4, and negative 1. And this comes from positive 4, negative 1, negative 4. Thank you for listening to my YouTube channel. I hope it helped you with whatever problem you are trying to complete. And if you'd like to learn how to do more problems like this, please be sure to subscribe. Thank you.